Okay, today we are going to do the next part of our integer or our exponents lesson, and we are going to start here where in our packet where it says quotient of powers property. Okay, so that's all we're going to focus on today, but we're going to add some extra examples. So to begin with on here, we need to write this in. So the quotient of powers property, we are going to reduce our base numbers and then we're going to subtract our exponents. So in general, if you have a base of a and an exponent of m, and it is divided by the same base of a and an exponent of n, then what you're going to do is keep the base a and you're going to subtract those exponents. Now, something to note is that when we subtract our exponents, it is always top minus bottom. We can't go the other direction. Okay, and so that's something that our first kind of note. All right, for example, example 4, and I rewrote it in case you can't see it, but it does say write an equivalent expression for 6 to the 5th divided by 6 to the 3rd. So what this is really doing is 6 to the 5th means 6 times 6 times 6 times 6 times 6 again. Okay, 5 6s multiplied by themselves. Now division in mathematics, what that really means is we can make that a fraction, right? So this means divided by 6 to the 3rd, you're multiplying 6 by itself 3 times, okay? And so in a fraction, you can cancel out same numerator and denominator because they're equal to 1. So I can actually cancel out 1, 2, 3 sets of 6s, leaving me with 2 6s left. So my final answer there is 6 to the 2nd power. Now, the shortcut, if you look at it, 6 to the 5th divided by 6 to the 3rd, if we keep that base of 6 and just subtract 5 minus 3, we get 2, and that's the shortcut. Now, that's if we have the same base. The examples that we need to add to our notes here are what happens if the base is not the same, okay? So if you move your paper up here, and I have this underneath, so hold on. Okay, so I want to add example 5 here. What happens if we don't have the same base? Well, if we have 5 and 10 as our base numbers and we have division, what we're going to do with the different bases is we are going to reduce. Okay, so we are going to reduce this as a fraction. And what I mean by that is if this were 5/10, right? To reduce 5/10, we see, okay, what number can I divide both 5 and 10 by? And that would be 5. So I would divide both the top and bottom by 5 and know that that would be 1/2 or 1/2. Okay, and so the first part of my answer is 1/2. Then I do my bases like I did above. So I have the same base of x and x. There is a hidden 1 on this x down here. So I'm going to keep that base of x and I'm going to subtract 6 minus 1 would give me 5. And this would be my final answer. Okay, one last one. So example 6 that I'd like you to write in is 12x to the 3rd y to the 4th over 9x to the 5th y. Okay, same thing here. 12 and 9 are different bases, so we are going to reduce them. Now, I know 12 is greater than 9. That is an improper fraction. We're going to keep it an improper fraction. So we're going to reduce 12 over 9. What number is the highest number we can divide 12 and 9 by? That would be 3. So I'm going to divide 12 by 3 and 9 by 3. So 12 divided by 3 is going to give me 4. 9 divided by 3 gives me 3. So that's my first part, is 4/3. And I'm going to leave it like that. Now, 3 minus 5 for my x's is going to give me a negative number. For now, we're going to leave it negative. Next week in our next lessons, I will show you what to do with that negative exponent. But since we're doing top minus bottom here, I will get 3 minus 5 is negative 2. And then the y, we're going to do the same thing. We'll keep the y on here. and we're going to subtract 4 minus a hidden 1. And so that's going to be y to the third. And this is going to be our final answer then for today. Next week, we will be going one step further and taking care of that negative, getting rid of that negative exponent. But for now, that's what we need to know. Okay, so that's the notes for the note packet today. The assignment that goes with it is a handwritten assignment by me. So it looks like this. Let me get this out of the way. Okay, here is the assignment that we're going to do today. It says quotient of powers on it. And so the quotient of powers assignment, we are going to have examples of many of these. So let's just start with a top one, a nice easy one, and then let's do one of each kind. So 5 to the fourth over 5. Remember, there's a hidden 1 there, okay? And so since we have the same base of 5, we're going to keep the base 5, and we're going to subtract. 4 minus 1 would give me 3 as my exponent, okay? And that's how we do 2, 3, and 4. Now, when we get down to number 5, we start adding different bases. So 3 and 2 are not the same base, so we need to see if we can reduce those, all right? So if what I mean by that is I would do 3 over 2 and see if I can divide 3 and 2 by the same number. Well, the highest number that I could divide 3 and 2 by is really 1. But if I divide by 1, I get the same thing. So sometimes that's the case. We cannot reduce it. So I know that I'm going to keep 3 over 2 as that fraction. Then I'm going to move on to the next. So I have R and an R. So I'm going to keep R on my answer. Remember, there's a hidden 1 there. So 3 minus 1 gives me 2. And that is going to be my final answer for number 5. All right, moving on. We're going to keep going. As we go down, right, we're going to have to this gets a little more complicated. Let's look at number 14, which is the most complicated looking one. Start in the beginning. So 14 and 6 are not the same base. So we need to see if we can reduce it. So 14 over 6. And we got to think in our mind, what's the highest number that I could divide 14 and 6 by? And the highest number really is 2. So we're going to divide each by 2. So 14 divided by 2 is 7. 6 divided by 2 is 3. So that's the first part of my answer is 7 over 3. Now I have x and a y. So I know I'm going to have x and y on my answer. Okay? So x, we're going to start. 4 minus 5 is going to give me negative 1. And 7 minus 4 on my y is going to give me 3. And that's how we're going to leave it for today. Okay, hopefully that gives you a good start on our assignment for today. If you have questions, please feel free to email me or come see me. The back of this paper says extra notes opener, and we're going to change this. This is going to be extra points, extra credit today for this assignment if you choose to do it, because this is a good review of what we've been doing the last few days. It's a good review of what we do when we multiply exponents. So if you can go back and remember how to do those, I will give you extra points. Okay, have a great day. I'll talk to you soon.